Hey guys, welcome to section 3E notes, piecewise functions. So today we're going to talk about a special kind of function called a piecewise function. And a piecewise function is literally built with different pieces of different functions, okay? So a piecewise function is built with pieces of different functions. So these different functions are kind of defined over different intervals. And then they're put together to make one singular function. So again, a piecewise function is just a special kind of function that's built with pieces of different functions, hence the name piecewise. And what we're going to do with piecewise functions today is simply evaluate them. So we're going to evaluate piecewise functions using a graph, which, by the way, we just did in our last section. There's just one extra little element added on when we're talking about piecewise functions. And then we are going to evaluate piecewise functions given an equation, which these equations look complicated and fancy, but they're really not that bad. So that's all we're doing with piecewise functions. We're going to evaluate them using a graph and evaluate them given an equation. So let's start with the graph, okay? So a couple different ways of asking these questions we have. The first one says, if x equals -3, then what is y? So I'm going to go to -3 on my x, that's right here. And remember, when I'm evaluating a function, I have to find where the graph is at x equals -3, and then I need to figure out the corresponding y value, which is +1. So when x is -3, the y value is 1. When x is 0, what's the y value? Well, x is 0 here, so I look at the actual graph. The x value is 0 at this point, and the y value is still 1. So the answer to this is 1. So now let's use function notation. If I have f of 2, then let's find the y value, or let's evaluate f of 2. Okay, so remember, the 2, the number inside those parentheses, is the x value. So at x equals 2, here's the point. And what's the y value? Well, once again, it's 1. Let's evaluate f of 4. So now I'm going to go to x equals 4. So here's x equals 4 on my x-axis, and now I get to go to the function. So the function at x equals 4 is right here at this red point, and the corresponding y value is up here at 3. So that's the answer. And finally, at x equals 8, what is the y value? We have to kind of extend the graph a little bit, assuming it's going to keep going like this. At x equals 8, the function should be right here, and that y value is 7. So far, this is really no different than what we did in section D. But then we get to something a little bit more fancy. This is a special kind of piecewise function that has what we call a jump discontinuity. In other words, it's disconnected, okay? Whereas this one is connected the whole time. This is disconnected. And so the graph kind of goes like this. It's going up, 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 and then it jumps up here and goes just horizontally, okay? And that's okay. That's allowed to happen with piecewise functions, but it's going to get a little confusing when we have to evaluate right around here. So it's not bad at all. Let's give it a try. If x equals -6, then what's y? So here's x equals -6. What is the y value? On the graph, it's down here at -4. If x equals -3, -3 is right here. So we go to the function, and the y value is -2. And then this one, this is where it gets a little crazy, right? Because this is where the jump occurs at x equals 0. So which one is it? Is the answer going to be 0, where this point is, or is it going to be 3, where this point is? Well, the answer comes from where the circle is closed. In a piecewise function, okay, whenever there is a jump like this, one of the points will be a closed circle, like the one down here. And the other point will be an open circle, like the one up here. When I evaluate at that jump, the y value will have to be where the closed circle is, because the closed circle tells me that the function is defined there. The open circle is like a little hole. It starts there, but the point doesn't actually exist there, if that makes any sense. So at x equals 0, the filled in or closed circle is here, and the y value right there is also 0. So the y value to this is 0. That's the special one where the jump occurs. Everything else is straightforward, okay? So everything else at x equals 2, the y value is up at 3. At x equals 4, the y value is also at 3. And at x equals 8, guess what? Y value still at 3. So that is evaluating a piecewise function that has a jump. And let's do one more just to hit it home, and then we'll move on to evaluating given the equation. In this one, we are given the equation, but we can also use the graph. So first one, f of negative 4. Negative 4 is right here. So the function exists at negative 4, where I just drew that red dot. So the y value is negative 2. F of 0. Okay, so x equals 0 is right here. So the function exists at x equals 0, where I just drew the red dot. And that y value is right there at positive 2. Then we get to f of 3. F of 3 is where the jump happens. Okay, so we got to look for the filled in or closed circle. So there's an open circle here at y equals 2, but that's not the answer because it's open. We got to do the closed circle, which is happening up at y equals 5. So x is 3, the closed circle is at y equals 5. So that's the answer. And then last but not least, f of 6, the function is up here. Oh, it's also at 5. All right. Now let's move on to the piecewise functions given the equation. So the equation's super fancy, but really it's just 3 different pieces. So I'm going to color code these. Let's start with green. This first equation is 2x plus 3, and then it says if x is less than 0. So this function is this equation only when the x's are less than 0. Okay? When the x's are in between the numbers 0 and 2, then the function is defined right at y equals 2. And last but certainly not least, if x is greater than or equal to 2, then the function is defined at negative x plus 1. So there's 3 chunks to this graph, all right? And again, we don't need to graph it ourselves. All we need to do is evaluate. So what I want to do is take a look at the first one and decide which part of the graph, the green, the orange, or the yellow, does this go into. Okay, so how do I figure that out? Well, remember, x is negative 1. That's the x value. So what I'm going to do is look at what we call these intervals, okay? So if x is negative 1, it only fits into one of these intervals. It's either going to be the green or the orange or the yellow. If x is negative 1, I hope you guys can agree that -1 is not bigger than the number 2, so it's not the yellow. -1 is not in between the numbers 0 and 2, so it's not the orange. But -1 is less than 0. So this gets plugged into the green. That's why I used the green pen, right? So let's take a look. We are only going to focus on this equation. So we're going to plug into just the green equation. 2 times -1 plus 3. So that's -2 plus 3, which is 1. So there's my answer. The fancy way to write this answer is f of -1 equals +1. But I would accept either way. Okay? Let's look at the next one, f of 1. So we have to decide, is the number 1 less than 0? No. Is the number 1 between the numbers 0 and 2? Ding, ding, ding. Yes, it is. 1 is in between the numbers 0 and 2, so this one I plug into the orange equation. Now, the orange equation is a little bit strange because it's just a number. And so there's no place for me to plug in x. Well, that's okay. The answer is just going to be that number that they give me. So the answer to this one is 2. So f of 1 is 2. That's the fancy way to write the answer. Last one here, f of 2. Now, 2, let's see, which one does it fit into? 2 is not less than 0. Now, is 2 between the numbers 0 and 2, or is it greater than or equal to 2? So you have to be careful because since this does not say less than or equal to, it is not the orange. Since the yellow says greater than or equal to, it's this one because x is equal to 2 falls into this category. So the next one is going to plug into the yellow. So the yellow equation is -x plus 1. I'm going to plug into that. So that's negative plug in x plus 1. So that's -2 plus 1, which is -1. Okay, so f of 2 is -1. That's the fancy way to write it. All right, so hopefully that's making sense. Let's do one more example, and then we'll call it a day. So example 2 of evaluating, I have 2 parts of this graph. We've got the blue chunk, where x is less than or equal to 1, or the red, where x is greater than 1. So let's see, 5 is greater than 1. That's going to go into the red. 0 is less than 1. That's going to go into the blue. And 1 is less than or equal to 1. So you plug the 1 or the number with the one that's underlined, okay, if it's the same number. So I hope that makes sense. Let's plug and chug, and then we're done. So starting with f of 5. Since that one goes into the red, I just plug into the red equation. So x plus 1, plug in 5, we get 5 plus 1, which is 6. So f of 5 is 6. Okay, next one, f of 0 goes into the blue. So we plug in to the blue equation. -0 minus 2. Well, -0 is just 0, minus 2 is -2. So we get f of 0 equals -2. Beautiful. Last one. The 1 goes into the blue. So we get -1 minus 2, which is -3. Oops. All right, so my answer is f of 1 equals -3. So hopefully that makes sense. We will practice in class when I see you guys next. And that is all for piecewise functions. Bye.